Hello guys, we're going to do this exercise here, try to find the arc length of y equals x cubed divided by 6 plus 1 divided by 2x, integrating with respect to x, so it's going to be dx from x equals half all the way to x equals 2. Okay, so let's do that. The formula of the arc length is going to be the integral of the square root of 1 plus dy dx squared, right? Well, dy dx is going to be, let's see, it's going to be 3x squared divided by 6 plus half. It's going to be x to the minus 1, so it'll be x to the minus 2. Right, it'll be minus 1 x to the minus 2. So you're going to do this, and this plus is going to become a minus. Right. Minus 1 x to the minus 2. Right, there you go. And we can simplify this. So it's going to be, yeah, I'm still going to have to keep this fraction separated. It'll be x squared divided by 2 minus 1 divided by 2x squared. And it's going to be this thing squared, right? I mean, this is dy dx right here. And it'll be squared. We got to square this thing. So let's do that. So it's going to be x to the 4th over 4 minus 2 times the first times the second, okay? So it's going to be x squared times 1 divided by 2x squared. Because you see, guys, it's going to be like minus, right? You got a minus in here, and then you have 2x squared divided by 2 times 1 over 2x squared. Well, this thing is going to be simplifying with this, so x squared divided by 2x squared. And that's what we have in here. Plus the square of the second term, which is going to be 1 divided by 4x to the 4th. Okay. So it's 1 plus all this inside the square root. Ew. Yeah. You know what? You know what I'm going to do? I'm just going to do the plus 1 in here. This one in here. I'm already going to add it all the way here, and I'm going to take the minimum common denominator because this is becoming ugly, and it's going to be 4x to the 4th, okay? Now, this is going to, Jesus, 4x to the 4th divided by 4 will be x to the 4th times x to the 4th, x to the 8th, Jesus, minus 4x to the 4th divided by 2x squared is going to be 2x squared times x squared, 2x to the 4th. Man, this is really weird. Okay, plus 4x to the 4th divided by 4x to the 4th, 1 times 1, 1, plus 4x to the 4th. Okay, so this is going to be x to the 8th, all right? And then you got plus 2x to the 4th, right? Because 4x to the 4th minus 2x to the 4th, 2x to the 4th plus 1 divided by 4x to the 4th. So it's the square root of all this, right? I know that I didn't do it organized in here, but it's because these things are so huge that I'm gonna draw a big, it'll be the integral of the square root of all this. Okay, I'm just gonna get this thing and move it over here, there you go. Okay, now you see the square root of and dx, right? So you have to do that, and it'll be from half all the way to 2. And when you take the square root of a fraction, you can take the square root of the denominator divided by the square root of the numerator. So this is going to be 1 divided by 2x squared, all right, over here. So I'm going to say that this equals, okay, it'll be 1 divided by 2x squared times the square root of the numerator here. Now, let's see. Let me think about this. You know what? This thing, I think, is the same as x to the fourth plus 1. And it is. X to the fourth squared x to the eighth, okay, squared, right? Plus 2x to the fourth times 1 plus 2x to the fourth plus 1 squared plus 1. Yeah, so this thing equals that. So I'm just gonna erase this here. And I'm gonna get this thing kind of like that, kind of like this. I'm gonna plug it in here. Okay, there we go. So since it's squared, you know, it's a square, so this is just gonna be like times x to the fourth plus 1, and it'll be dx, right? Or yeah, you still have to integrate. I still have to integrate this thing, right? Because it was blah 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 da da da. Okay, yeah, I still have to integrate this thing from half all the way to 2. Okay, so you know what I'm gonna do to make this easier? Instead of using because I got an x function in here and I got an x function in here, instead of using the differentiation function, I'm just gonna keep dividing this. So it's gonna be like half to 2, all right? X to the fourth divide, I'm gonna separate this thing, okay? X to the fourth divided by 2x squared is gonna be x squared over 2, plus 1 divided by 2x squared dx. So let's keep going here. I'm gonna keep going here. So now I'm gonna integrate, and there's something else too that I think that I'm forgetting. Hold on. No, I think this is good. It'll be the integral of that. Yeah. Okay. All right. Let's do it. So now it's gonna be x to the third divided by 6, right? Plus, and now you have to integrate this stuff. So I'm just gonna do half, and it'll be x to the minus 2. All right, so it'll be x to the minus 1 divided by minus 1. So I'm going to put an x in here, and I'm going to replace this plus with a minus. And now I have to do this, because I still got to plug in the values, okay? So all I got to do is plug in the values now, and now it's going to be 8 divided by 6 minus 1 divided by 4 minus, I'm going to open up a parenthesis here, it'll be half, right? 1/8 divided by 6, one will be 1 over 48 minus, so yeah, this is like 2 times the half in here, okay? So 2 times, just think about this stuff and plug in that half in here. It's just going to be 2 times half, which is 1. So this is going to become just minus 1, okay? All right, yeah. And now all I got to do is erase this thing here and change the signs. So I'm going to erase the parentheses. And I'm going to change the signs. So this is a plus, becomes a minus. This is a minus, becomes a plus. Now let's do this here. I think divided by 225, yeah. Okay, so 48 divided by 6, 8 times 8, 64, minus 48 divided by 4, that's going to be 12, right? Yeah, 12 here. And then I have a minus 1 and a plus 48 equals, well, let's do this here. This is going to be a minus 13. So 64 minus 13 is going to be 51, right? And a 51 plus a 48, it'll be a 9, and it'll be a 99, I guess. 99 over 48. Yeah. And I guess you can, let me just see here. Then we have 52, 51, 99 over 48. And you can simplify this thing for 3, okay? So I guess this becomes a 33, and this one becomes 16, and a 3, no. I think that's it, guys. 33 over 16, that'll be the length of this arc in here, okay? So let's see. Yep, that's it. I got it right. I didn't make any arithmetic errors in here this time. So that's the final answer. Okay, 33 over 16 will be the length of this stuff in here. So what does that mean? That means that, let's just say that you have this end right here. Okay, you grab this with your left hand, and you grab this one with your right hand, and you bring it down all the way to the level of this one here, like that, like so. So you're gonna bring this end down over here, okay? And if you measure something like this, you're going to get 33 over 16. That's the final answer. Okay? There you go. For now, I think that's it, guys. I'm not going to make any other exercise. I'm not going to do any other exercises now. Solve exercise. I'm going to leave the rest to the next video. I just wanted to get started on the exercises of finding arc length. Let me see. Maybe I'll solve another one. Okay, I'll solve another one. Okay, let's do this. I'm going to paste the stuff in here. All right. So it's the same thing. The arc length of the graph of y on 0 to 8. So here we don't have y as a function of x. We have x as a function of y. So we're going to do, it'll be the integral. Okay. Well, if it's from 0 all the way to 8, it's x that's doing this. You could do it from 1 all the way to 5. Let me just check this thing. Yeah, you can do that. You can do that. Even though it says the arc length of the graph of y on 0 to 8. 0 to 8 is going to be the value of x, but we're going to integrate with respect to y, and y is going from 1 to 5. So we're going to integrate from 1 to 5, okay? The square root of 1 plus, and now we're going to have dx dy squared. All right. This is still going to be tough because you have this. Okay. Well, anyway, there's something else, guys. Since we're talking about arc length, I don't think we have to worry about the plus or minus square root, because you cannot have a negative length. Okay, you can have a negative displacement, but when you're talking about length, you're talking about the distance, and you cannot have a negative distance. The distance is always going to be greater than or equal to 0. Okay. Just to make it clear, let's just say that you're here with your car and you do this, and you end up in the same place. All right. Now, what was the displacement? The displacement was the final point minus the initial point. The coordinates at the final point minus the coordinates at the initial point. Since you ended up in the same place that you started from, the displacement is 0, but the distance, you had to go through all this distance in here, okay? So the distance is greater than 0, but the displacement is 0. And when you're talking about arc length, well, we cannot have a negative length. So, yeah. So I guess you don't have to worry about the minus. But anyway, okay. There's something else in here. You do see this equation, you have x squared equals the y minus 1 cubed, right? So in order to take this x squared away, what you want to do is to take the plus or minus the square root of this stuff. Well, here's the thing, a negative, okay? Let's just say that you choose this negative in here. So you're going to have a negative x. Do you have a negative x in here? No, all this is positive x, so you don't have to worry about the negative. So let's do that. Since this is squared, okay, you do this, okay? So you take dx dy is going to be equal to 3 over 2, and then you do y minus 1. 3 halves minus 1 is going to be 1 half, so you do that, okay, times the derivative of the inside function. The derivative of the inside function with respect to y is just 1, so forget about it. So you got to square this stuff. Why? Because look, you have to square it, okay? So squaring this is going to be 9 over 4 times y minus 1, okay? That's what you get. So, yeah, because you see y minus 1 to the half, and when you square it, it becomes y minus 1. So, it's 1 plus this stuff, okay? Yeah, it's 1 plus this thing. So I guess, because this is the squared, right? I gotta do this. So this is the thing squared. So we gotta add a 1 in here. And you know what I'm thinking? Maybe I'm gonna put a 4 here, and this I'm gonna turn into a 4, okay? So it's gonna be 9y minus 9 plus 4 divided by 4. Now 9y, I don't know if I should do this. Let me check one thing in here. Okay, so this is going to be 9y minus 5 divided by 4. Okay, so that's what I'm going to put in here. It will be 9y minus 5, everything divided by 4. But you see, I'm already going to take the square root of 4 here, so you can, it's the square root of everything, okay? It looks like it's the square root of just the thing, but it's the square root of everything, the entire fraction. So this is going to be a half, so I'm already going to put, I'm going to transform this into a half in here, okay? And this is dy. And I'm going to take this thing out because I already took the square root of 4. So it'll be the square root of 9y minus 5. Okay? That's what we ended up with in the end. I mean, that's what we ended up with. Of course, it's going to be in the end. Okay. So let's see. So you have the integral of half, okay, from 1 to 5 of 9y minus 5 to the half dy. Let's do that. The half, I can put it outside because it's kind of drag this over because it's a constant. So let me erase this. So let's do that. This thing here is going to become 9y minus 5 to the 3/2 over 2/3, okay? Divided by the derivative of this with respect to y, which is just going to be 9. So this is going to become a 27. All right, okay? Yeah. And because you have this 2 and that 2, I'm going to simplify this 2 with this one. So this doesn't exist anymore. And I have to integrate this, right? From 1. As a matter of fact, I've already integrated it. Okay, all I gotta do is to plug in the values. So let's see. It'll be 9 times 5, which is going to be 45 minus 5, 40. So it's going to be, oh yeah, and there's something else too. It's to the 3/2. Yeah. So it's going to be 40 to the 3/2 over 27 minus, and you have this 27 in here, so I'm already going to put it in there. And then you have 9 minus 5 to the 3/4. 9 minus 5 is 4. So you have 4 to the, to the 3/2, right? This is what you have. Anyway, so let's do this thing in here. 40, you see what you have here is like 40 times 40 times 40. This 40, you can, these two in here, you can just grab, take them out, and then you're going to be left with the square root of 40, okay? So I'm going to put the 40 in here, and I'm going to reduce this thing here to 1/2. There, all right? And over here is going to be the same thing. It's going to be 4 times 4 times 4 to the square root of, to that stuff. So I'm going to do 4 times, and this thing here, I'm going to transform it into 1/2. Like that. Now, what is the square root of 4? It's 2. So I can just put 2 times 4 is equal to 8. So this is going to be an 8 here. I know it's messy, guys, but what can you do? Math is messy. All right. And here you have the square root of 40. Well, here's something else that we can do. We go like 40, okay? Let's try to factor this out. By 2, you got 20. 2, you got a 10. 2, you got a 5. And 5, you got a 1. So this is going to be the same thing as the square root of 2 cubed times 5. Well, this is going to remain in the square root, and this 2 is going to come out. So I'm going to put an 80 here. Okay. I'm going to put an 80. And this thing here is going to be the square root of 10. Because can't do anything about that. All right. And I think that'll be it. Yeah, I'm right. I'm right. When you do this in a calculator, okay, you do like the square root of 10 times 80 divided by 27 minus 8 divided by 27. When you do that, you get approximately 9.073. So what is 9.073? It's the length of this arc in here. Okay. If you stretch this out, because you see that it's curved, right? It's like this. Well, if you stretch it out over here, that's what you're going to have. You're going to have a length of approximately 9.073. That's it, guys. That's it for this video. See you guys on the next one.